Some drugs fit their receptor like the perfect puzzle piece, locking in tightly, while others barely fit or stick in the wrong spots. But what does that really mean? In this video, we're breaking down two key pharmacological concepts, affinity and selectivity, by answering two simple questions. First, how tightly does a drug bind to its receptor? And second, how well does a drug choose the correct receptor? First, the answer to how tightly does a drug bind to its receptor is affinity. Affinity describes the strength of the interaction between the ligand and its receptor. Higher affinity means tighter binding. Affinity mainly depends on first, shape compatibility, how well the drug matches the receptor's structure. Second, binding forces, interactions like hydrogen bonds and ionic attractions between the ligand and its receptor. Now, an important term to be familiar with is the equilibrium dissociation constant, also known as KD. It is the concentration of a drug at which 50% of the available receptors are occupied at equilibrium, and it's a measure of the affinity of the drug for its receptor. Now, looking at the curve between drug concentration on the x-axis and the fraction receptor bound on the y-axis, if we pointed where 50% of the receptors are occupied with the drug and trace it down to its corresponding dose, we call this dose Kd. So, the rule is when Kd is low, the affinity is high and the drug binds tightly, which means only small concentration of a drug is needed to occupy half the receptors. Meanwhile, when Kd is high, the affinity is low and the drug binds weakly, which means higher concentration of a drug is needed to occupy half the receptors. Now, to the left, we have the curve between the drug concentration and the fraction receptor bound for two drugs. Drug A shown in green and drug B shown in red. If we pointed where 50% of the receptors are occupied with the drug and trace it down to its corresponding dose, we determine Kd for each drug. And as we can see, Kd for drug A is lower than Kd for drug B, which means drug A has higher affinity than drug B. The second question of how well does a drug choose the correct receptor, answered by selectivity. Selectivity is about choosing the right receptor and ignoring the wrong ones. Why does it matter? Because highly selective drugs are precise and safer, and highly selective drugs reduces unwanted side effects. Now, to sum up, the best drugs have high affinity and high selectivity. Now that we've put the puzzle pieces back together, it's time to see if they really clicked. Let's quiz. Question number 1. A drug that binds strongly to its intended receptor but also interact with several other receptor types is best described as A, B, C, or D. Question number 2. Drug A binds tightly and only to one receptor. Drug B binds weakly and to many receptors. Which is correct? A, B, C, or D? If you learned something cool today, smash that like button and hit subscribe for more bite-sized medical lessons. Drop your answers and questions in the comments. Until next time, stay curious.